Many years ago, a wise man once told me, why spend 5 minutes doing something when you could spend 5 hours failing to automate it? One of the secrets to productivity in life is automation. As I plow through life, I try to delegate anything repetitive to the robots so I can focus on the things that are really important in life. When it comes to automating software development, my favorite continuous integration and delivery tool is GitHub Actions. Recently, I've been working on getting an NPM package called SvelteFire production ready. And in today's video, I'll show you how I save tons of time by automating this project. But first, what even is a GitHub action? Well, when you host your code in a repository on GitHub, there's a ton of different events that can take place, like you might push some new code to the main branch, or another user might do a pull request to merge changes into your code, or maybe someone opens up an issue because your code sucks. There's a huge list of potential events that can happen to a repo. Now with an action, you can trigger some code to run automatically when one of these events take place. In the background, GitHub will spin up a magical cloud computer, also known as a container, that's built to your specifications and runs your code to automate things like testing, deployment, and so on. Computing things in the cloud of course costs money and is billed per minute, but GitHub has a generous free tier that most projects won't exceed. To get started, just create a hidden GitHub directory in the root of your project, followed by a workflows directory. Then inside of that, create a YAML file that can be named whatever you want. Now, before we create our first workflow, there's one project that I would highly recommend you install called Act. This is a CLI tool that will emulate GitHub workflows for you so you can test them locally. You'll also need to have Docker installed and running because what it does is build out an actual container just like it does in the cloud with GitHub Actions. If you don't have Docker on your machine, the easiest way to get it is to install Docker Desktop. Once you have Act installed, you can run the Act command, which by default will emulate an on-push event to run any workflows that are tied to pushing code to the repo. You can of course customize the event to test different workflows or just run the workflows individually. Now we're ready to define our first workflow, which will test our code automatically. Writing tests for your code is never an absolute requirement, but when building a library like SvelteFire for other people to use, it's extremely important. Not only will testing help prevent bad code from getting into a release, but it also makes your life way easier when you have other people contributing to the project. With GitHub Actions, we can automatically run our tests in the cloud, and we'll know immediately whenever a pull request comes through if that contributor broke the existing code. This project's actually somewhat difficult to test because it deals with cloud data, but currently we have Playwright tests in place, which allow us to test the code in a simulated browser environment. Now let's go ahead and set up a workflow to run the test automatically in the cloud. First, you give the workflow a name just to identify it. Then most importantly, the on property will tell GitHub on which events to run this action. In our case, we want to test our code whenever we push it to the main or master branch. However, we also want to test code whenever a pull request comes through. That's requesting to merge code into the master branch. Now that we have our events configured, we can define one or more jobs, which is the actual code that will run in the cloud. Give it a name like build, and then specify an operating system for it to run on, like Ubuntu is usually the best default. One cool side note here though is that you can also use a matrix strategy to run your jobs in multiple environments like Windows and Linux. It's not really important in our case, but it's a good thing to know. Now, every workflow job is broken up into a series of steps, and this is the part where we tell the robots how to do the things that we would otherwise have to do manually. The first step uses the uses option, which is a keyword that allows us to use pre-built steps. Like checkout will bring the code from the repository into the container, and then setup node will add Node.js and npm to your path. I'm also using the with keyword to specify node 18. Now that we have an environment set up the way we need it, we can use npm CI, which is the equivalent to npm install, but does a clean install, which is what you want for automated environments. And then when it comes to Playwright, it recommends using npx instead of your local binaries. So we'll go ahead and do that for the install and the testing of Playwright. And that's really all there is to it. We now have automated testing set up on this project. Now go ahead and run the act command, and it should build out the container and test your code locally. One other cool thing I want to show you though when it comes to Playwright is that there's another step we can use called upload artifact. What this will do is save the Playwright report as an artifact in the GitHub Actions environment. That means if your tests do fail, you can go into the artifacts and get a detailed report of what went wrong, and then they'll be automatically deleted after 30 days. Now that we have automated testing in place, let's take a look at automated deployment. Many hosting platforms like Vercel and Netlify do this for you automatically nowadays, but it's super easy to do on your own. With SvelteFire, I'm building a dedicated documentation website with Astro. Now, anytime anything changes on the master branch, we want the documentation to automatically update and redeploy to Firebase hosting. Now, the documentation website is basically its own isolated project in this docs directory. So in the workflow, we're going to set the default working directory to the docs directory. That means in our build steps, when it runs npm CI, build, and deploy, those commands will be run from the docs directory. And that's almost all the code we need for a deployment workflow. However, we can't just deploy to Firebase hosting without being authenticated. In this case, we need to set up an environment variable called Firebase token, but it's a super secret value, so we can't just hard code it here directly because this code will be committed to a public public repo. Luckily, we can go on the GitHub Actions dashboard and store the secret environment variable there. Now when this workflow runs, it will have access to that value and thus be able to deploy the site to our Firebase account. That takes care of deployment, but SvelteFire is an NPM package, and that means when we release new code, we also need to publish that package to NPM so people can install it. You wouldn't want to create a new package for every time code is committed to the master branch, because a simple typo fix or something wouldn't require an entirely new release. A better trigger for NPM publishing is when you manually create a new release on GitHub. Typically what you'll do is release a new version and add some notes about the things that changed, then in the background the workflow will run to publish that code on NPM at the same time. Like Firebase deployment, it's also going to require authentication with a token. And then one other thing I want to point out here is that whenever you define a step, you also have the option to give it a name, as well as a few other options beyond that. Giving your steps a name is generally a good practice because if something goes wrong, it'll be more descriptive, which makes it easier for whoever's trying to debug the workflow. And when things do go wrong, you get a nice breakdown of all the logs on the GitHub Actions console. In rare cases, an action might fail for no reason, in which case you have the option to rerun all the jobs if you suspect it was just some kind of temporary issue that should now be resolved. And that brings us to the final workflow that I want to show you. This one exports data from the Cloud Firestore database to a storage bucket. However, that event is not tied to any specific event in the code. Instead, it happens on a schedule, which is defined with a cron job. This is really cool for any project because it makes it really easy and cheap to run arbitrary code in the background on a specific schedule. I also have workflows that generate daily reports and things like that. But you'll also notice that this particular workflow can also run on the workflow dispatch event. This allows you to manually trigger the workflow. You can do it directly on the browser, or I'd also recommend installing the GitHub CLI, which will allow you to trigger workflows there manually as well. The GitHub CLI is cool and will allow you to monitor things in production, but it's not a replacement for Act, the CLI tool we looked at earlier, which is more useful when you're doing the initial setup of workflows and testing them locally. To finish things off, I want to give you a bunch of examples of other workflows that you might want to set up for your projects. We've already looked at testing, but another thing you might want to do is automatically lint every pull request as well. Essentially, this does an automatic code review. You don't have to manually go through and make sure that the code meets your stylistic standards. When it comes to maintaining a project, there's all kinds of different things you can do. Like you can automatically mark issues stale if they haven't been interacted with in a long time, or you can automatically label and respond to issues, which makes it look like you're actually maintaining the project, even though you've already moved on to building a brand new JavaScript framework. Now, in some more advanced cases, you may want to develop your own custom action that you can reuse across multiple projects, or publish for other people to reuse. There's a project called Actions Toolkit that can make that process much easier. It provides all the tools you need to interact with the Actions environment using TypeScript. Before you build your own custom action though, there's a good chance that somebody may have already solved the same problem. There's a repo called Awesome Actions that gives you a list of all the different actions and tools available in the ecosystem. Now, another thing worth pointing out is that by default, GitHub will host the actual machines that run your code. However, it is possible to self-host your own runners. I've never actually done this myself, but just wanted to point it out as an option if you don't want GitHub to handle the compute, which would be running on Azure Cloud. I mean, who really knows what Microsoft is doing with all that code they're running? In any case though, GitHub Actions is an awesome platform, and I would highly recommend using these free robots to get stuff done. Thanks for watching, and I will see you in the next one.